Good morning, good afternoon, and good evening, everyone, or wherever you're from, or I could just say good day. Welcome to the Azure Community Conference 2020. Today in this session, I'm going to introduce you to Terraform and infrastructure as code with Terraform. This is a fundamentals and a level 100 kind of a session. We'll start with very basics and go to maybe deploying a Azure web application using Terraform configuration files. So briefly about me, my name is Ravikanth Chaganti. I'm a distinguished member technical staff at Dell EMC. I'm a published author with books around topics like PowerShell desired state configuration, PowerShell remoting, Windows management instrumentation, and a few more coming up soon. I have worked extensively on infrastructure automation, and Terraform is certainly one of the tools I love most. Now, with the introduction out of the way, let's look at the agenda for today. So I want to really start with explaining why Terraform is needed, why a tool like Terraform is needed really. So we would cover basically the concepts like infrastructure as code and the difference between configuration management tools and maybe provisioning tools and so on. And then we'll move on to Terraform Basics. We will see how to install Terraform, how to write your first configuration, and then understand a few more things about the configuration workflow, what exactly Terraform configuration workflow is, and then look at a bit more complex example of deploying Azure web application. And as in that process, we'll look at different things like the expression syntax in Terraform configuration files, and also some of the concepts like modules within Terraform. All right, so let's get started with the first item. Why Terraform? Why do you need Terraform like tool, right? Now, if you look at the older traditional IT infrastructure management landscape, the processes used to be very tedious, labor intensive, and error prone. When you have to implement a new workload, or when you have to increase the capacity of an existing application infrastructure that you had to plan well in advance so that you can order these physical servers and then bring them into the data center, rack and stack them, and then deploy and configure those servers. Now, over a period of time, what happens is the initial deployment could go very well. You install the operating system, you get the application running on top of it. But over a period of time, you tend to tune the OS parameters or the application configuration based on reasons like performance optimization, or it could be troubleshooting a specific issue, or making sure you working functionality that you desired it to be working as. You kind of work around to make it happen by changing maybe on Windows, let's say, some kind of a registry settings, etc. Now, over a period of time, what happens is these manual deployments and configurations lead to snowflakes, right? A snowflake is something that cannot be replicated very easily, right? So you end up with a server which has a lot of custom configuration, which everyone is very scared to touch, right? The moment something happens to that server, recovering to that known good state of that server is kind of mostly impossible unless you're using very processes like standard processes like documenting every change that you want to do and making sure all the changes actually go through a change control board, and then you have a configuration database that's actually tracking all these changes that are happening to these systems and so on. Now, while the processes exist, it may not always be the thing for some of the admins. They might actually go make a change on the server without actually going through the right processes and so on. We just still end up with Snowflake servers which cannot be replicated when you actually need to rebuild any of those application servers again. Now, with the emergence of virtualization, containers, cloud, and web scale infrastructures, these traditional ways are challenged, right? With virtualization, you have multiple servers, like in virtual machines, right, actually running on top of a single physical server. Now you have got that physical server racked and stacked, and you configure the hypervisor, etc. Now at any point in time, creating another server instance for your application is just about creating a virtual machine. It's just a few clicks away, right? And with containers, that's even more easier. You just have to really take the container image, bring up, and then make sure that you have the right applications running inside that, or the services running inside the container. With cloud and web scale infrastructures, again, the same concepts really play a role here. On demand, you can just go create a virtual machine in the cloud, or you can just deploy a database instance in the cloud, this platform as a service, and so on. With companies like Netflix, Facebook, and others actually deploying many times a day, the existing traditional processes did not really scale. That's where the concepts like DevOps and infrastructure as a code came into picture, right? The paradigm shift from the physical hardware in traditional data centers to virtualization, containers, and then cloud, and the web scale infrastructures running in the cloud. There's increased focus on agility in the infrastructure management, and that introduced a concept called infrastructure as code, right? This is a Wikipedia definition here. Infrastructure as code is the process of managing and provisioning computer data centers through machine-readable definition files rather than physical hardware configurations or interactive configuration tools. That's a whole lot to digest, but to simply put, the way you deploy your applications today should be the same way you deploy your infrastructure as well. That's what, in essence, infrastructure as code is about. What you really do when you have to deploy an application, you kind of have maybe a continuous integration delivery pipeline, which basically takes care of validating your application code, performing unit testing and maybe some kind of integration testing, and then pushing it to a staging environment, making sure the deployed application is functional, and then moving it to a production environment, deploying it basically to a production environment at a later point in time. Now, if you apply the same practices within the infrastructure management and infrastructure deployment as well, that's what you really get as a part of infrastructure as code. All right, so now that we have a fair understanding of infrastructure as code and what is infrastructure as code and why was it even needed, let's look at some of the core infrastructure as code principles. The first thing that comes to my mind is the version control or the source control for your infrastructure code as well. Similar to your application software code, you also need to have your infrastructure code kept in the version control systems. It could be ad hoc automation scripts, or it could be configuration files, or it could be anything that basically automates your infrastructure provisioning and configuration. You should always have that in your version control systems. The second part is more important, declarative configuration. Now, if you look at the traditional or the typical way of doing automation of your infrastructure deployments and provisioning is that you write a bunch of scripts which are more procedural in nature, right? I mean, you basically create a script that basically has n number of steps. Step 1 does something, and step 2 might take the output from step 1 and do something on top of that, and so on. Like, you might have n number of steps within that. That's called more of an imperative nature or imperative way of doing things, where you basically tell the computer through your scripting or programming language what needs to be done and how it needs to be done, right? Whereas when it comes to declarative configuration, we basically tell the computer how to configure a specific infrastructure, or how to provision a specific infrastructure by just describing what you need, right? For example, if you take an example of Azure PowerShell or Azure CLI, you basically go write multiple commands. First, you create a resource group. You then create a virtual network specifying that this is the resource group where the virtual network has to be created. You create a bunch of subnets, and then you create a virtual machine. You attach this virtual machine to the subnet, and so on. These are the n number of steps that you have, right? And in that process, you basically use different commandlets that do basically each of these step configuration individually. And then when it comes to declarative configuration, we don't necessarily tell how it needs to be done. Instead, we just specify that you need a virtual machine with so-and-so subnet, which is in the virtual network that you specified, and which is in the resource group that you specified. That's all, right? The underlying automation takes care of performing the configuration for you, the provisioning for you, and then making sure that whatever you have specified in your declarative configuration is deployed as desired, right? We'll see an example of declarative configuration when we actually start seeing some of the Terraform basics. Now, the third point, which is idempotency, is another very important aspect. When you are actually running your imperative scripts, the ad hoc automation script that you have created, you basically would specify, like I said, earlier, a number of steps that you have created, and each of those steps you basically have a lot of error handling related syntax. If this particular resource group already exists, don't do anything, or if it doesn't exist, go create it, right? Similarly, you have to create such a conditional constructs within your scripts or programming language that is actually doing your infrastructure provisioning. Whereas when it comes to declarative configuration and in general infrastructure as code, the idempotency principle basically says that any number of times you apply this configuration, there should not be any change if the infrastructure is already provisioned as you want, right? If you have to really do that in an imperative script, you have to take care of all these aspects of error handling, making sure that the resources do not exist that you want to create, and so on, right? So that's where the declarative configuration and the tools that actually are in the space of infrastructure as code basically take care of these things for you automatically in the behind the scenes, and that's where idempotency really becomes important. The last point here is your infrastructure as code, whatever you generate to provision your infrastructure, should be modular in nature, right? You can of course create 1,000 lines of Terraform configuration, but would it really make sense? Not necessarily, because someone who's going to maintain that, or any updates that you want to do a variable name, or you want to change something within a specific resource configuration, if it has dependencies on other resource configurations, etc., or rather other resources depend on this change that you're making, any mistake in one place would actually cause a failure in the provisioning of your infrastructure, right? So instead, if you can actually modularize your configuration into different smaller chunks, that way you have more control over what you want to update and how you want to update that. So your infrastructure as code principles basically are version control, declarative configuration, idempotency, and modular, right? Now Terraform, being one of the provisioning tools within the infrastructure as code space, supports declarative configuration, it supports idempotency, it supports modular way of building your Terraform configurations. Now you can take all this and put it in a version control system. Now you have something that a process that basically implements all of these infrastructure as code principles. Terraform is certainly one of the best tools within the infrastructure as code space. There are many others. You have configuration management tools like Ansible, Puppet, Chef, PowerShell DSC, and so on. They're configuration management tools, and Terraform is basically the provisioning tool. The difference is provisioning tool is basically, think of it like the outside configuration, right? You want to create a virtual machine, you want to create a virtual network, you want to create let's say if you're using Terraform for vSphere and so on, you want to create a virtual machine inside a vSphere cluster, a ESX cluster, right? That's the outside configuration. You're provisioning the infrastructure that is needed to run your application, right? And the configuration management tools are predominantly the inside configuration, right? They take care of the inside configuration. Let's say once you've created a virtual machine, inside that virtual machine, you want to install an application. You want to configure that application to do XYZ things. Now that is the inside configuration that we talk about. So provisioning versus configuration management in a 30,000 feet level can be described as inside versus outside configuration, or outside versus inside configuration, right? So Terraform basically is implemented to support provisioning of your infrastructure. It can also, using a concept called provisioners, we will look at that in a bit. Using that concept, you can actually run some code inside or run your scripts, etc., inside a virtual machine that you create, or inside any other kind of infrastructure that you provision using Terraform. But Terraform by design is called a provisioning tool. It implements all of these infrastructure as code principles that we just described. So let's look at some of the Terraform basics before we go write our own first configuration. So Terraform has this concept of a core, right? Whatever is the minimal required support to implement some of these infrastructure as code principles is implemented as core, right? Now you extend that core to support different cloud providers like Azure, AWS, and so on by writing plugins, right? There are different types of plugins. The first type of plugin is a provider plugin. One example of that would be Azure RM. That's what we will see today. And each provider supports basically resources and data sources. Resources are what you want to configure. Data sources are basically a data set that you can retrieve from the cloud service and use it as a part of input to your Azure resources that you want to configure within a Terraform configuration. The second type of plugins are provisioners. Provisioners are basically, like I said, you want to do some inside configuration. Once you complete the provisioning, you can use some of these provisioners like Ansible provisioner, or it could be a remote exec and so on, etc. That will actually go perform the configuration that is necessary inside the virtual machines that you just provisioned or inside the infrastructure that you just provisioned. The local exec is basically a provisioner which will basically run something. Let's say once your Terraform configuration is applied successfully, you want to run a provisioner locally to do something more that you need in terms of logging or in any other aspects, right, on the local system, like maybe saving some of the Terraform state files or etc. and so on. There could be a number of use cases within that space. Now, so how do you get Terraform? Terraform basically can be downloaded from the terraform.io website. Let me quickly take a look at, show you that. So if you go to products, Terraform, you can either go like this. There are different editions that you see. There's an open source, there's a cloud, self-hosted. For this session, we kind of focus only on the open source part of it, right? There's also Terraform Enterprise, which is again outside the scope of this discussion today because we are just looking at the fundamentals. Now, if I go here, I have the download CL option, and when I go to downloads, I have for different operating systems. I'm running Windows, so I can download either 32-bit or 64-bit or whatever. It basically gives me a .zip file. I need to extract it to a folder, set the environmental variable in Windows to path environmental variable to point to this particular folder, so that from any console or any command prompt, if I execute Terraform, I basically see that specific executable and then be able to perform without actually specifying the full path to terraform.exe. So I have a simple script here, a PowerShell script, which will basically help you download this and set the environmental variable as you need it, right? So you can run that. For example, this is available in the code sample that I've shown in the first slide. So you can just run it like this. All right, so now that the Terraform download is complete, the environmental configuration is also set. I can just do Terraform -- version and basically see that this is the version that I have installed now, or downloaded rather. And then if I just do Terraform, it basically gives me help content with respect to what are the different types of commands that I have, and there may be some other commands that are possible along with this. All right, now that we have Terraform downloaded locally, let's go back to the slides and look at some more basic stuff, like what is the basic syntax of a Terraform configuration. Terraform basically uses Hashicorp configuration language HCL to write the declarative configuration files. This is a kind of a pretty basic and minimal high-level kind of a syntax. You have a provider block which basically says what is that provider that you want to use as a part of this configuration to perform infrastructure provisioning. In this case, I'm using Azure RM. The features block that you see inside this is a mandatory block, although they have not specified anything. That must be specified as a part of Azure RM provider block. The second one that you see is a resource block. I have Azure RM resource group as the resource that I want to manage right now or create. And I have a name given to this block. For this particular resource I'm creating, I just have a name called TFRG1. And within this block, I have a bunch of parameters like, what is the name of the resource group, what is the location of the resource group, and what are some of the tags that I want to assign to this particular resource group once it is created. So there are different ways. I mean, for example, when you're actually running this configuration, let's say you have to authenticate initially to the Azure cloud and then start deploying any of these resources that you specified within the configuration, right? So there are multiple ways you can do that in with Terraform, or rather this is with Azure, and Terraform basically supports these different methods. Azure CLI for interactive use, it's a pretty good way of authenticating. For example, right now I'm doing this demo. I have used Azure CLI to log in to Azure cloud already. And then whenever you log in with Azure CLI, it basically stores your profile and tenant ID, subscription ID, etc. in an app data folder locally, so that Terraform basically now can look at that particular folder, get all the authentication related details from there, authenticate for you automatically before you kind of start creating any Azure resources. The other ways of doing things, you have Azure AD service principal, client ID, and the client secret that you can use. You basically create an Azure AD application registration and then take the service principal, client ID, and the client secret from there. Specify that in a Terraform configuration. I'll basically show an example of that in a little bit later. And then start using your Terraform configuration the same way you would use with Azure CLI after that. The third method would be to use, instead of a client secret, you can use a client certificate and then perform the authentication with Terraform and Azure. The last one is Azure Managed System Identity. Let's say you want to run your Terraform configuration inside Azure virtual machines that you already provisioned in Azure Cloud. You can use the managed system identity. You can assign a system managed identity or user managed identity to that particular virtual machine and then have that run your Terraform configuration. In that case, you don't necessarily specify anything other than just one parameter, which can be specified as a part of the provider block within the Terraform configuration. So for all the demo purposes here, I'm going to use Azure CLI, which I've already mentioned, right? So once you have the authentication complete, you need to really understand how to use Terraform. There's a specific configuration workflow that you have to go through. That's what we'll see next. So whenever you have a Terraform configuration, you basically do an init first, which is not there in the slide, but once you initialize, it basically downloads whatever providers that are needed for the configuration, whatever other modules that are needed for the configuration, and initializes your environment for Terraform plan to happen. Now the plan phase is basically used to determine what needs to be created, updated, or deleted, right? It's basically looking at your current state of the infrastructure and finding out what is there in the configuration file, whether it is present in the current infrastructure state or not, and then telling you what will get created, updated, or deleted. The second part, the second step would be to actually perform the action, right? You want to create a resource group, or you want to update a resource group by adding new tags, or you want to delete a resource group, etc., right, per the plan. So you want to perform the action. That's why you use Terraform apply command. Now, if you want to destroy a provisioned infrastructure, you obviously use the destroy command, right? Now, let's take a quick look at this configuration workflow with a simple configuration of creating a resource group. All right, so this is a very simple configuration that I have here. I have a main.tf file which basically has a provider block which specifies Azure RM as the provider, and the features block inside that is mandatory, although I don't have any other properties mentioned within that or attributes mentioned within that. And I have a resource block which is for the Azure resource group. I've given it a name, here. This is the name of the block, or rather this instance of Azure resource group resource specification. And then I have a location where I want to create this resource group, and I have the tags that I want to implement as a part of the after the resource group is created. Now what I'm going to do is just move into the right folder and then run Terraform init first. Just take a look at what it does. It's actually downloading the latest Azure RM provider from Terraform registry, Hashicorp Terraform registry. And then once that is complete, it'll actually prepare the environment. You'll see this folder getting created here. For example, .terraform folder, and within that you have the registry and you have the Terraform provider exe file here, right, for the Azure RM provider. Now, once this is complete, you can now do a Terraform plan. That's what the command also says here, right? I'm just going to copy that, paste it. Also, just run it for now, right? Terraform plan will now basically look at what you have in the configuration file, the .tf file, the main.tf file, and see the cloud services within Azure and check whether this specific resource group already exists or not. Right, in this case, it does not exist. So the Terraform says that it's going to add one resource, and the plus sign that you see here basically says that this particular resource will be added to the cloud service using the Azure RM provider. Now what I'm going to do is do a Terraform apply, and then say auto approve, so I don't have to really get the prompt and see the prompt and then type yes there. It'll just auto approve the deployment. It'll run the plan again, since we have not specified a specific plan, the Terraform plan file that it should be looking at. It'll just do a plan again, and then since we provided auto approve, it will start deploying that resource configuration automatically. This will take a minute. While that's happening, let me just show you that I probably don't have the resource group. I don't know if it's already created since the configuration is running already. So if I go to resource groups here, I don't have that yet. I hope so. Yeah, it's not there yet. If I go back to my console, it's created now. There's one resource added. So if I refresh here, I should be able to see that resource group. Yeah, you see it here, right? Now that resource group is created, if I go to tags, I should be able to see the tags that I created, right? So I should have a couple of them, owner and the purpose, right? So what really happened here is, if you take a look at the directory structure again here, you have something called a terraform.tf state file created. Now when you do a plan, basically tells you what Terraform intends to do based on what you specified in the configuration, right? And once the configuration is applied, what it generates, while it creates the resource as you specified in the configuration, it also stores the state of that resource as a part of a .tf state file here, right? Terraform.tf state. Now this is your source of truth. Now next time when I execute, let's say again the Terraform plan, it will basically look at the Terraform state file which is locally available, and then it will also look at the current state of the resource in the cloud service, and it will tell you if there are any mismatches. It will point out those mismatches and then say these are the XYZ things that need to be updated, right? So in this case, ideally it should not show any changes because we have not changed anything in the configuration. All right, so no changes, infrastructure is up to date. Now let's go intentionally make a change here. Let's add maybe a new tag called project, and we'll make it, we'll call the project maybe Terraform demo project. All right, now let's do a plan again. It should ideally now show that there has to be one tag that needs to be added to this resource group. And that when you apply after this point, it will actually now show that that new tag being added, and then the state file getting updated after that. Right. If you actually see the tilde basically shows that this particular resource will be updated. In this case, the tags properties are getting updated, and this particular tag is getting added. That's a plus sign indicates. Right. So let's look at Terraform state. Pay attention to the serial number here, right? And if I go run apply again, as the tags get added, you would see that these values change here. The serial value changes here. That basically is kind of a version of your Terraform state. Every time you update something, this is a Terraform state file also gets updated. All right, so one changed, and you see the serial is now set to 3. And if you look at the things that have changed, so you can see that the new tag that we added just now, the project, is already available here, right? So that's a quick demo of showing you how to write a simple configuration and how to go through the configuration workflow that Terraform basically supports or required. All right, so now that you understand the basics of Terraform configuration syntax and how to go through the configuration workflow, let's take a look at a bit more complex example of deploying an Azure application app service, right? So let's move to VS Code again. What I'm going to do is rename this. I don't need this any file anymore, and then use this for the next demo. So before we go to the app service, I just want to give you guys some more information on the new syntax within Terraform 13 onwards. So in this syntax, you can basically specify something like this, right? A Terraform block, which is there in 12 also, but if you actually look at the required providers here, I've specified Azure as an alias to the Azure RM provider, and then I mentioned source as Hashicorp Azure RM, a version with a specific version constraint here, which is basically specifying that anything with 233.0 in this case 233.0 I mean .x is okay for this configuration file, right? And in the provider block, I've specified the features, which is I said mandatory, and the environment as public, right? I've also mentioned about using client ID, client secret, or the client certificate, and so on, that you can specify using these different values here. If you want to use MSI, the managed system identity, you can use the MSI endpoint or the use underscore MSI set to true. So then the Terraform configuration assumes that you're running inside an Azure virtual machine, and it will use the managed system identity and the endpoint that is there within the virtual machine, and then connect to the Azure Resource Manager as an authenticated resource and perform the configuration provisioning for you, right? And you can of course create multiple resource groups. In this case, you can have multiple instances of a specific resource. In this case, I have 2 resource groups getting created here. Right. So let's move on. I don't want to really execute this because we have already seen an example of this running. Let's go to the example where I mentioned. I'll show you app service. So in this case, again, I've kept these as kind of a standard thing here now onwards. Just creating one resource group, and I'm creating a Azure virtual network, and then adding some subnets to it. There are a couple of subnets. So one is called an integration subnet, and the second one is an endpoint subnet. And then I'm adding a service plan for the app service, and then creating an app service for the front-end web application. And I'm making sure the app service and the subnet ID, they are kind of using the network Swift connection here. It's basically performing a VNet integration connection. And then I have a backend application, a DNS private zone. The idea of this configuration here is to basically show you how to use multiple resources within a Terraform configuration, right? And finally, I have a private endpoint that is used for the backend web app private endpoint. Now, one of the things that I want to point out here is the way we use the interpolation here. Right? I mean, not necessarily interpolation, but how we basically create explicit dependencies. Right. So when you're creating any infrastructure, you have certain dependencies, right? For example, when you're creating a cluster, you need to have all the servers within the cluster running the cluster service, right? So making sure that to be able to run cluster service on it, all of these nodes have to be accessible and so on. That there are dependencies between configuration of different nodes, etc. Very similar to that, if you actually take a look at the Azure resource group here, a particular VNet configuration requires this Azure resource group, right? This VNet cannot be created unless a resource group exists already where you want to place that particular VNet. So this here, for example, the location or the resource group name, whatever the way we specified, this is essentially the resource name dot the name you have given to that particular resource block dot location this property or dot name this property. So by doing so, you're actually creating an explicit dependency here. So this is how you basically refer to the properties of other resources within the same Terraform configuration file. Let's try to execute this and see what happens. I don't have to really do Terraform init since I already have it, but simply execute that and see what happens. I think we have a newer version of Terraform plugin. I mean, the Azure RM provider here in this case I think it is 236. But whereas in the new configuration that we are just working on, I've specified that I've put a resource constraint saying that it should be 2.33.x or something. So it's actually downloading 2.33.0. Let that finish. And once that is done, the Terraform init will be complete. We can do a plan and apply after that. Sorry. Now I have this thing done. I'm not going to run Terraform plan anymore because Terraform apply already does that for me. So I'll just do auto approve. And they should run Terraform plan and then perform the actual execution of my Terraform resource configuration itself. All right, so now we have the entire resource configuration completed, and you have 11 resources added to this. If you look at the Terraform state file, you should have each of those resources mentioned here along with their properties that are derived from the current state of the resource, right? So this is what I have here. The way you destroy a configuration is basically we looked at the Terraform command for that. It's destroy, and you can simply say auto approve. It's gonna destroy this entire configuration. Let's run this and destroy the existing, whatever infrastructure that we just deployed right now, so that we can move on to the next demo to show you something more. All right, so the destroy operation is complete as well. All right, so let's look at the final configuration example for the session. In this example, I basically have the first few blocks set to something same as the earlier configurations that we just looked at. The Terraform settings configuration, where we specified what is the required version of the Terraform binary itself and the version constraints for it, and then the required providers and the version constraint source and version constraint for this particular Azure RM resource provider. I've added a couple of variables here. Essentially, variables are a way to parameterize your configurations, right? You don't want to kind of hard code the values of, let's say, things like resource group location or tags, value of tags, and so on, right? For that matter, a lot of values for your resource properties should be taken from the variables or input parameters to ensure that your configurations become reusable. That's one of the infrastructure as code principles also, right? You want to be able to reuse your configurations, by providing multiple different types of parameter values and deploying different types of infrastructure using the same configuration, wherever possible, right? So moving on, looking at this particular variable block here, right? The difference that you see here is this variable block does not have the default argument, whereas the second one, RG_purpose, has a default argument. So this becomes an optional variable. Since I already specified a default, this will be used if an explicit specification of this variable is not provided. But whereas this has no default value, so RG_location is a mandatory variable in this case, or a mandatory input parameter. Now the way I use that variable value is, this is how it is done. We have looked at a similar syntax in an earlier example, but if you look at var dot RG_location, so var basically represents variable dot what is the name of the variable that you have defined earlier, RG_location, RG_purpose, right? So this is how the variables are used. The next block is about a storage account that we are creating. Again, no surprises there, as long as this is the resource that you have to use for creating a storage account, and you can derive what are the different types of attributes that you have to specify for that particular resource looking at the documentation. Now the next interesting part is this one, module, right? A module is basically a way, so once you have created, let's say, a parameters configuration, you want to reuse that entire configuration in a different configuration file that your team member is creating, or some other team is actually trying to use the configuration that you've parameterized already. Now what you can do in that case is you can package your configuration as a Terraform module and share it with them, and this is how they can actually import it or use it within their new configuration that they're creating. So essentially the module block, I have given a name to that module block, and then specified a source where it should be downloaded from, or where is it available. In this case, I'm downloading it from the Terraform registry, and I'm specifying any of the required attributes for that particular module, right? If you go to the Terraform registry and go to browse modules, let's take a look at any of the Azure RM modules. I have the network. So within this, you see that there are certain input parameters. For example, in this case, for this particular module, resource group name is the only one that is needed. The optional inputs are basically other attributes that you can specify, but they're optional anyway, right? Now, after that, what I have is a data block, which is basically used to derive some data set from the storage account properties essentially. And if you actually look at, I have explicit dependency mentioned here. In the earlier example, if you go back to that, whereas we have mentioned here that this is going to create an implicit dependency on the particular resource group, so that the resource group execution happens first, and then it comes to the subnet or whatever private endpoints that we have specified where the dependent resource is. That execution happens at a later point in time. Similarly here also, the data block gets executed only after your module.static web execution is complete. So there's an explicit dependency that we are specifying here using the depends on attribute. And finally, what we have here is the output block. Once your configuration is complete or your infrastructure is provisioned, let's say you want to retrieve the value of a specific endpoint that you have created just now, right? Maybe you want to use that in a different configuration file, or you want to use that in your automation, etc. Whatever is the purpose is, you can, as a part of your output block, you can return multiple such values as output from this Terraform configuration. All right, so let's try to execute this. Before I can execute, I need to kind of download, reinitialize this Terraform configuration, because I may have the same Azure RM provider version and the Terraform binary also, but I don't have this module locally installed, right? I have to download it from the registry. So let's do our Terraform plan again. Sorry, init again. So it's going to download that. And then it's using the same version that we already have. All right. So in this case, I just do a Terraform apply. I don't want to go through the plan again. I'll say auto approve. Now, the question comes here, before I execute auto approve, I've mentioned that this particular variable is a mandatory variable, but I've not specified the value. So how it's going to work, right? With the Terraform apply, you can specify a parameter called var, and you can say rg_location equals, let's say, West Europe or whatever it is. You can specify that here. Or there's a better way of doing that. You use something called a terraform.tf file. It's just a kind of a text file where I have the parameter name and the value of it specified here. So what Terraform does is, anytime it tries to plan a configuration or apply a configuration, and the configuration has variables or mandatory variables within that, and if there's no input specified as a part of the command line, it will go look for this particular file called terraform.tf in the same location as the configuration, and then it will start using with the value specified within that. Let's see. All right, so while that's running, let's take a look at the slides again and give you some resources. So the demo content for this session is available in my GitHub repository. You can access it at /AzConfDev2020. And then there's Terraform documentation, which is excellent. You should read, ideally, the documentation to figure out a lot of syntax, for the resources that you are planning to use as a part of your Terraform configuration. And I'm also doing a Terraform Zero to Hero workshop tomorrow. That's 26th November 2020. So this is going to be a day-long workshop. If you have not already registered, go explore if there are vacant slots and register for this session. Also, I'm writing this book on Terraform with Azure, Zero to Hero. It's basically going to cover everything that you need to know about using Terraform with Azure. In that process, I kind of plan to cover a lot of things related to Azure, resource manager provisioning with Terraform, by explaining different Terraform concepts, right from very basics to the things like CI/CD for your Terraform configurations, Terraform Cloud, and a lot of tips and tricks and troubleshooting in that whole process itself. Right now, this is still under development. I have a couple of chapters complete. You may be able to buy this book at this link, leanpub.com/tfaz02h. All right. That's all I had for today, and looking forward to see you in person next year.